everyone. So here we have Puneet Singh. Very good afternoon. Uh, this is our very first class. So as you have suggested, Puneet, I have the topic which we will discuss, the derivative of the functions. Right, derivative of the functions. So if we have learned the function y is equal to fx, okay. So we have Jaswinder Singh also. Jaswinder, welcome in today's class, right? So we will discuss about these derivatives, okay, derivatives of trigonometric function, derivatives of inverse trigonometric functions. First we'll start with some rules. Like we know that the derivative of a constant function is 0. There are some rules for the rules. So first we know the derivative of a constant function, right? If a function is a constant function, right? The derivative of a constant function is 0. Okay, that is the constant rule. If we have derivative dy dx of, let the constant function is c, represent a constant, and d by dx of that is always 0, right? That the derivative of constant function is 0. Then we have the constant multiple rule, constant multiple rule, multiple rule, that if we have a function, right? If we have a function that is the derivative of, right? Like we have the derivative of this constant multiple rule, the constant term will come first, and f dash of the derivative of function c remains same, right? So this is the constant multiple rule, right? So next we have that is called power rule. Generally it is used power rule, means if we have the derivative of, like here we have x raised to power n. So we have learned in our previous class, right, that n, the power becomes first x raised to power n minus 1, right? What is it? N x raised to power, this is n here, and x raised to power n minus 1 here, n minus 1. So the derivative of x raised to power n, that is n into x raised to power n minus 1, right? So the next is, here are some rule. The next is next one, that is the sum rule. The sum rule, if we have the sum of two functions, right, the derivative of, we have f of x plus g of x. then its derivative, that is f simple, that is the derivative of the first plus, in the same way if we have the difference sum rule and difference rule, right? So derivative, that is f of x minus g of x. In the same way we have, that is f dash of x, derivative of first minus derivative of the second function. Okay, so next we have that the product rule if we have the function fx into gx, right, the derivative of the when we have two functions multiple product rule fx into gx, then we have the first function as it is, first function as it is into first function fx into g dash x plus, then we have second function as it is gx into f dash of x. Have second function as it is gx into f dash of x. Right? So this is the product rule, and the next, that is your the quotient rule, right? So let me erase it. I hope you have noted on all these. Next one, that is your the quotient rule. Quotient rule, that is the derivative of f f dash x. So here, so example we will discuss first. Puneet, some example by solving some questions. So I actually, dear Puneet, I don't have any book here available. So I'm just discussing the basic, you can say these the formulas, right? So I'm not, don't have that. By next lesson, I will take questions or from your the textbooks, right? From grade 11 textbooks or grade 12. So presently, I don't have the text here. So kindly note on these, and I will discuss. You can say derivatives of your trigonometric function and inverse trigonometric functions, right? So because we will learn these rules while solving these questions, the exercises, right? So please note down these timing. The product rule, after the quotient rule, you will start with gx into f dash of x, right? F x on gx, right? Minus here and here we have gx whole. Here you have to go with the square. Okay, gx raised power 2 here, and we have one more that is called the chain rule. This is also important, chain rule, right? In chain rule, what we have, that dy dx derivative of the function f, here f of gx here, right, is this is first differentiation of fx with g of x, and then we have the differentiation of, right. So let me discuss with you some of the derivatives of some of trigonometric functions, right. The derivative of some trigonometric functions, you have to remember these derivatives of trigonometric functions. Derivative of some trigonometric functions, right? Let me start one. What is, you have to remember now this dy dx of sin x. The derivative of this trigonometric function first is dy dx of sin x. It is always equal to cosine of x, right? And second, that what is the, that is d by dx of cosine x, derivative of the function cosine x, that is minus of sin x, minus of sine of x, right? And the derivative of tangent x, tangent of d by dx here, tangent x is equal to secant square x. Okay, what is dy dx of, or derivative of tangent x is equal to secant square of x. And here I have Deepak Singh also. Deepak, very good afternoon dear, welcome in today's class. And the derivative of the cosecant x, okay, d by dx of cosecant x is equal to, here we have, that is minus of cosecant x cotangent x, right? And then we have derivative of secant dy dx of secant x, secant of x is equal to, that is secant x tangent x, the derivative of secant x is equal to secant x into tangent x. And one more last, the derivative of cotangent x, of cotangent of x, cotangent of x is equal to, cotangent x is equal to minus cosecant square x, minus of cosecant square of x. So you have to remember all these. Derivative of sin x, that is cosine of x. Derivative of cosine of x, minus of sin is minus of sine cosine, and cosine is minus sine. And derivative of tangent x, secant square x. Cosecant x minus of cosecant x, cotangent x. And secant of x, secant x, tangent x. And the derivative of cotangent x is minus cosecant square x, right? So these are some trigonometric functions. Okay, I have We can also learn few trigonometric inverse functions, derivative of inverse functions, trigonometric functions. You can also note down. We have some other functions and their derivatives like exponential functions, logarithm functions. So we have to learn step by step and we have to solve some based on these derivatives, right? So these are basic trigonometric functions, derivative of basic trigonometric functions. Now take the derivative of inverse trigonometric functions. Derivative of inverse. Derivative of inverse trigonometric function, right? So first one is the derivative of sine inverse of x, that is 1 upon, always 1 upon under root 1 minus x square, right, where x is not equal to plus minus 1, right. What is the derivative of sine inverse x? 1 upon 1 under root 1 minus x square, and where x is not equal to plus minus 1, right. In the same way, derivative of cos inverse x, the cos inverse x, that is minus 1 upon under root 1 minus x square, and where again x is not equal to plus minus 1, right. X square, here is 1 upon under root 1 minus x square, and here it is minus 1. Here it is minus of 1 upon under root 1 minus x square, right. So this is the derivative of cosine inverse x. Then derivative of tangent inverse, derivative of d by dx of tangent inverse x. The derivative of tangent inverse x is 1 upon 1 plus x square, right. What is the derivative of tangent inverse x? And derivative of tangent inverse x is equal to 1 upon 1 plus x square, right. So next one, that is cotangent inverse, that is the dy dx of cotangent inverse of x, right. Cotangent inverse of x, that is minus 1 here, plus it is minus of 1 upon 1 plus x square, right. It is minus 1 upon 1 plus x square. Now we have derivative of secant inverse. So let me discuss here again. Derivative of sine inverse x, 1 upon under root 1 minus x square. Derivative of cosine inverse x, that is minus 1 upon 1 minus x square, and the derivative of tangent inverse x, that is 1 upon 1 plus x square, and derivative of cotangent inverse x, minus of 1 upon 1 plus x square. Now we are left with the derivative of secant inverse x and cosecant inverse x. the derivative of that is dy dx of secant inverse x, right? The derivative of secant inverse of x, that is 1 upon x into x square minus 1, what is it? X into x square minus 1, where this x is equal to minus of 1 upon x into x square minus 1 again is not equal to plus minus 1 comma 0, right? So these are some of the derivatives of the inverse trigonometric function. So I hope you people have started your syllabus. So tomorrow we will discuss your syllabus also, some of the topics. How I have get a message from Puneet yesterday immediately when I shared the schedule for the class. So I will let you know about this bridge course will are helpful in your grade 11, right? So within 1 or 2 days we will frame, you can say that the structure, and according to that we will pursue our course. Okay, we will pursue our mathematics, okay, according to the tentative this chapter wise. So I hope you have understood all these derivatives of these trigonometric functions and inverse trigonometric functions, right? So you have to remember all these while finding the derivatives, the rules which we have discussed, whether there is chain rule, product rule, addition when two functions are added or subtracted, we will apply these rules, right? So let's shift to let's check some of the questions related with your algebra part, right? So take my first question. Now we have discussed in grade 11 also, we are generally discuss like your quadratic equations. Okay, in quadratic equations, we know the standard format ax square plus bx plus c is equal to 0, right? We have learned that by splitting middle term, completing scale method, also, and by quadratic formula, the two zeros, they are minus of b plus minus under root b square minus 4ac on 2a. Right? Now, nature of roots, we are only nature of roots. Nature of roots. Nature of roots is determined by, that is the discriminant, which is equal to b square minus 4ac. Okay. The nature of roots, it was determined by, nature of roots is determined by the discriminant. What is the discriminant? B square minus 4ac. Now we have three situations. One, when we have this discriminant greater than 0. Second, when this discriminant is equal to 0, and third case when this discriminant is less than 0. So we know all that in the first case we have the real and distinct roots, real and different, or even distinct, two real and equal roots, real and equal roots, and here imaginary roots, no real. In previous classes we are saying these roots, no real roots, but these, okay, these are complex. Start solving. Just provide me the feedback here. Some internet issues. Check whether the video is okay, my voice is audible to you. Just provide the feedback. So in quadratic equations we have many, it is used in so many, you can say, real life situations. Okay, thank you Puneet. Puneet is saying okay, it's fine. And in algebra, actually today I have not planned to go ahead with the derivatives. Okay, so as you have suggested, Mr. Puneet, we have discussed about this. Jaswinder is also there. Thank you, Jaswinder. So we can have some situation, like situations here, like sometimes we have given the area of the squares and the perimeter also. So we can have, in the real life situations, we can only solve, or we can find the solutions only by framing these quadratic equations. Okay, whereas in algebra you have also studied the pair of linear equations, how to solve these pair of linear equations. Then the polynomials, that was also important, because in now higher grades you have to study your like binomial theorem. Okay, or in CBSE also there are so many topics which are essential in mathematics, right? So there is one more topic, that is a mathematical induction is there, PMI, principle of mathematical induction. Okay, and there are some other, even we have a very important the topic in grade 10. Up to grade 10 we have studied your cone and the circle or sphere. Now we are in grade 11, we will study about the conic section. We will study about the conic section, that is also important part. Conic section. In conic section we will study different shapes like of your parabola, hyperbola and ellipse, right? So with respect to your circle, we will study these conic section also, and there are some other probability and these statistics. They are always a part of the mathematics. Grade 11 also we will study these. Okay, so it depends upon your those students who are going for AS level or with CBSE also, in both the courses, whether AS or your CBSE, these are very common topics, and we have to start with the higher version of these particular topics, and one by one we will discuss all these topics, right? So with this I am ending today's class. So thank you to Jaswinder and Puneet and Deepak also. Deepak has also joined the class. So thank you very much for joining today's class. So you know, again we have the classes from Monday to Saturday, right? Tomorrow I think I have the class little change. Monday, Tuesday and Wednesday we have the same time class, that is 12, 10 to 1 o'clock, and Thursday, even Saturday is the same timing. Saturday or I think Friday, you can check the timetable, right? So with this I am ending today's class, right? So tomorrow I will, you can discuss, okay, you can WhatsApp me what content you are going to discuss or start first, okay, and I will know the tentative plan which for this month of December, how many chapters we want to complete, okay. So with this, thank you very much. God bless you all. Stay safe and stay healthy.